Hi, this is Timon Sloane with the Open Networking Foundation. I'm really pleased to have Google joining us as part of the Spotlight on Broadband series. And today, Hani Elmalky from Google, who's the Google architect in charge of access technologies, will be joining us and sharing his perspective. So Google, Hani, take it away.
Thank you, Timon. Thanks for the introduction, and thanks for having me here today. So I'm here today to talk about broadband and open source. And I have to start by saying that we had an amazing journey with open source and broadband over the last few years. I mean, we see much of the projects now starting to get into much of the project that actually started with direct contribution from both operators and vendors and live deployments, and now actually they are getting into production. So these are really amazing times for all of us. And what I'm trying to talk about today is how can we focus on the end-to-end of broadband and what the community can deliver to push it to the next level. So without further ado, let me start first by highlighting what I mean by broadband. I'm sorry for borrowing a legally proof definition of broadband as per the FCC, but basically the FCC sees broadband as a high-speed switched broadband that enables user to originate and receive high-quality voice, data, and graphics. And maybe we need to stress down the high-quality piece of it, because I know that most of us now under COVID-19 struggle with working from home with the video, all these video streams on high definition, where basically our speeds are not good enough to be able to supply such type of demand. And to be honest, there's a reason for this. I mean, the 2010 definition of the high speed was looking after 4 megabit per second for the downstream and around 1 megabit per second for the upstream per user. And that was maybe at that time was good enough for what the users are doing. And that's why we were expecting that let's start from there and see where we will go next. And actually it went down, it went really well. I mean, it has multiplied by 6, not good enough yet. And unfortunately the uplink stayed at 3 megabit per second, which is only a multiplier by 3. The challenge though is in 2020, under COVID-19 crisis, the assessment from FCC with regards to the high speed didn't change. And that's really what I'm struggling with. I mean, today we need to really look into how can we get users with much higher speeds than what we see on the numbers that you see on the screen. And to be honest, I mean, the challenge here is twofold. I mean, the first challenge is how can we get a wider coverage at higher economical viability for operators to be able to support these type of deployments. And the second piece is how can we really push the speed forward? I mean, the challenge right now is it looks like we are hitting both the economical challenge with laying down fibers on the ground, not to mention the fact that actually the coverage in itself in terms of the build practices to be able to go after the rural areas and the unprivileged areas is quite challenging. And that's why we need to look into how can, as a community, contribute to how we will get the speeds in 2025. And to start tackling this, let's first spend some time trying to understand what are the possibilities of, what are the possible technologies that are available today at our disposal. And currently, as you see on the screen, we have the fixed access, which is wireline through fiber or cable that will go either over FTTX or through a cable to the final households or destinations, versus the other approach that's actually started to roll out in some of the United States cities and worldwide with fixed wireless access, where we see 4G LTE is used to deliver broadband services to end users over wireless residential gateways. And that's all good. The challenge though is that we see 1 gig over here or less, a little bit, but it's actually much higher than the 25 meg that we saw from the FCC definition. But unfortunately, with the fixed wireless access, the speeds are a little bit challenged because of the bandwidth and throughput. And let's take them piece by piece here. So the first one, with FTTX, the build cost and time is definitely a problem. And of course, the rural coverage is quite challenged. It's actually, I would say, it's more like a civil engineering problem rather than being an electrical or software problem. And then with regards to the fixed wireless access, crowded spectrum is not making it easy for us to promise a higher sustained rate than the existing mobile broadband, which yielding to a low access speeds. And of course, CBRS may help, but the question is always, is it enough? I mean, can we assume that CBRS will allow us to fix the spectrum issue? And then the challenge is always about like the duality of the access technology here. You don't see it converge in a way that will allow a single provider to be able to go after both. I know that the status quo right now is a little bit different because we see a lot of service providers who's able to do mobile and fixed, but reality is when they realize this on their network, they are not converged. They are two parallel verticals, and that what will make hybrid access quite tough in some single neighborhood where we actually want to tackle the community with more or less like both fixed and wireless in the same time. So then the 5G may carry some solution for that. And I think a lot of people are believing that the new radio together with 5G will be able to allow us to get even a better fixed wireless access service. And that's, to be honest, true. Yet, we see another convergence problem between 4G and 5G because you see two different options for either standalone or non-standalone. On top of that, the better radio access is good, but we still have the spectrum problem. But they are going to be better speeds, but is it going to be enough for what users need? And finally, CBRS also is at our disposal, but the question is it enough? Then the conversions continue to be even a bigger problem, trying now to converge both 4G, 5G, and wireline. And the challenge here is not the fact that we don't have the technology to get it done. The challenge is each of these technologies can be a solution on its own in a greenfield. But reality of the service providers right now is actually that they are all in brownfield. They all have wireline core, and they have some investment in their upper layers when it comes to business support systems. And switching the core or the handler of the core is quite tough for them. And now I want to highlight also another important point. All these layers from access perspective are logically separated, but they are all physically overlapping. Like we are serving the same area with 3 different pieces of technology. And on top of that, from core perspective, maybe the northbound is different per generation, but reality is that's our choice. And reality as well is that these different components are just handling different tunnels. They are doing exactly the same job, but on different tunnels. So the question right now is, do we really need 3 different components? Then if we take this a little bit further and try to find, okay, how can we get 5G to help? And I think the proposal here is to use fiber to the 5G endpoint. So this means that we will be able to shrink down the size of the base station coverage a little bit, which will allow us to increase the speed. And this will definitely also allow us to have a more economical way to get the fiber drops because by replacing them with wireless drops to the end users. And that, as I said, will also address the low reach of the 5G high band, where basically the propagation properties of a higher band frequency is most probably challenging from distance perspective. That's why maybe shrinking down the base station footprint will allow us to have a little bit of higher speed access. And I think that's something that even the FTTH Council in Europe agrees with. I mean, as per their economical assessment, they believe that 65 to 96% of fiber costs for 5G X-Hole can be eliminated if we use the existing infrastructure, which technically means that if we leverage the current FTTH network, the incremental cost to deploy 5G in that area is around 1 to 7%. And that's really, these are really good numbers for operators. The challenge though is how can we get it done? I mean, if the viability economically is there, then how can we get it done from a technical perspective? And here what we are proposing is basically, can we somehow as a community figure out a way to get both fiber and new radio as an access technology merged together, and in the way that allow us to address both fixed wireless access towards end users. And in the same time, the challenge with this one is, can we also somehow figure out the way that the core will work? And couple of points here we need to consider. The first one is because of our way of designing how the access will work from the RG. We are looking into a dual access problem when it comes to the next generation RG, because we are looking into an IP over Ethernet over GTP to be able to facilitate the new radio to 5G core, which is, again, that's by design. That's how it will go. And I don't think it's efficient. It's an MTU problem, and I don't think we need all these headers in order to get that to work. It also will give us better speeds. The question is it enough? And then finally, the CPRS. So these are all three problems that we need to figure out if we can fix. Then the other set of problems is, do we really need two gateways over there? Do we want to have a gateway to terminate the GTP tunnels, basically as per the UPF definition of the 5G release 16 and 17, or 3GPP3 release 16 and 17, or we can do something better. Maybe we should eliminate the wireline gateway itself. But then the question is, what will happen to the wireline core when it comes to the brownfield implementation, as I said before? And then the northbound interface is definitely a problem. And then finally, I'm sure we can simplify this a little bit. And that simplification, I believe, will allow us to have at our disposal a very unique way to be able to address the rural areas with the wireless as the last mile, while keeping the FTTH for the more dense areas. So now, trying to map what I just said with the projects that we have in play today at ONF and other open source communities. So for SD-RAN is definitely a way to go when it comes to how can we get the new radio mapped with fiber, addressing all the timing issues that we see with CPRI and other things. So basically utilizing ORAN, utilizing the SD-RAN framework, we may be able to figure out a way to handle that piece of the problem. Then SEPA as a framework is actually promising quite an extensible framework to be able to include new radio as an extra as an extra access technology in there. We will need to figure out a way to how to make this work on the hardware perspective, because now we are seeing both the OLT handling the FTTH and of course the digital unit and radio base station together with the rest of the front end, the phone hole of the 5G network. So that will be like an interesting project from open source perspective. How can we figure out that unified platform that allow us to both handle both FTTX and new radio from the access network perspective? Then the Open Mobile Evolve Core is actually giving us the piece related to terminating the GTP tunnels, either with 5G or 4G, for both 5G or 4G. And then COMAC will allow us maybe to have a unified way to handle both. But the question is, can we trust it to be able to handle the potential northbound interfaces that will come with a brownfield deployment? And I'm not trying to say that we need to carry all the northbound interfaces from legacy systems, but we definitely need to figure out a way to be able to hook to a brownfield deployment without significant uplift and without significant forklift on the higher level of the network. And then I also want to highlight that it's not only ONF project, but also the Telecom and Infra project have the Open Core network that is trying to more or less address the same use case, maybe with a little bit of a different color, but they see Open Core network as a way to build a core that actually will tackle multi-access technologies with a unified system or a unified node in the packet core. And so, in summary, basically, we have been on an amazing journey, as I said, and community continue to challenge the status quo, which is great. And open source projects are getting into live deployment worldwide very swiftly these days. And what we want to do now is to step up for the challenge, which is the data demanding is increasing. COVID-19 crisis is also increasing the pressure on the telecom industry to find means to address the speed scarcity problem in general. As I said, our ways of life today requires more bandwidth at the house. So we need to figure out a way, how can we get that to our users? Not to mention users that's actually not even covered with broadband yet. And I think the convergence between both wireless and wireline from technology perspective can carry the key to address the economical viability of the access speed increase. And I do believe as well that the open source ingredients exist. I think the question is how can we mix them in the right way to simplify the overall use case. I'm not sure if that makes sense. Maybe you can give me some feedback here.
No, Hani, that was great. And really, I think a nice perspective as well. I mean, I think that one of the main takeaways from this is a motivation to really collapse mobile backhaul, which was historically a distinct space on its own, and the fiber broadband network, and leverage that same asset. And the primary benefit there being around leveraging the fiber assets, which are of course maybe the most expensive and difficult asset for the operators to actually get deployed efficiently. What occurs to me though as a question is around timing requirements and running timing over the network. Historically, or not historically, but technically, mobile networks need strict timing, and broadband networks much less so. So I wonder if you put any thought into what's required there, for, in terms of converging those backhaul networks.
Yeah, that's a great question. So I think the PON as a technology is not good enough to handle the CPRI as it is defined today, the interface between the digital unit and the radio base station. And that's in itself a challenge that we know for years. Yeah. The point though is with Open RAN, where basically we are actually virtualizing both the base station and the digital unit are becoming more like servers, and the eCPRI is actually taking place. The timing perspective now can be relaxed a little bit, and I think that's a technology question that we need to get experts to be able to answer. But my point here is, can we leverage the FTTH infrastructure as an IP bearer between the digital unit and the base station? And from that perspective, if we are virtualizing that component deeper into the network, then maybe the existing infrastructure of PON may be easily leveraged to be able to address these type of use cases. That's one thing. The other thing is 5G is not going after fixed wireless access only. There's 83 use cases for 5G. The question here is, can we as a community figure out the right mix of what we need out of 5G to be able to get broadband right? And maybe at that time, especially because there is no mobility in fixed wireless access, then maybe even we can relax the timing constraints for that single specific use case, because basically we are not expecting soft handoffs between the base stations, and we're not expecting mobile users. What we are expecting is users who's connected steadily on the network with higher sustained rate, and they would appreciate a failover if the base station went down or if there's interference. That's what we need to optimize for. And that's, I think, the volume problem that 5G is trying to take with a single size fits all, which is great for maybe mobile operators, but for broadband, fixed broadband, the bar is less. So maybe we can actually get going with what we got today. So to re-answer your question, timing is a problem for legacy CPRI/PON, but today with the eCPRI Open RAN, we can use the PON as a transport carry for the IP packets itself, which technically allows us to relax the timing in timing constraints on it. And on top of that, the fact that we don't have mobile subscribers when it comes to broadband coverage in that specific fusion of fixed and wireless, then maybe we can also reconsider the fact that we need different timing constraints when it comes to serving broadband on top of 5G fusion with fiber for fixed broadband customers or fixed wireless access customers. Does this make sense?
Yeah, no, it does. Good, thank you. So, so switching gears a little bit, I think you did a great job of laying out this whole portfolio of ONF projects, and you're right. They're projects that fit, almost all the different pieces of that end-to-end solution that you outlined. And envisioning kind of taking those pieces and mixing them in slightly different ways to create a solution here makes a lot of sense to me. it also happens that we're doing this session as part of the broadband series, and there are a lot of mobile components that you're describing in here too. And those two worlds are starting to kind of come together in a bunch of ways, and certainly our work is overlapping in many ways. But apologize to the broadband audience if there's some mobile terms they don't know. But I think since those two worlds are colliding, it's important that we all become well versed in both spaces. The other thing I'd add that you didn't touch on is sort of the UPF work, or the user plane work, and that ONF is undertaking and has a community and ecosystem building around leveraging P4 and more optimized hardware to be able to take the user plane function, separate it, that CUPS architecture, and then from there also pushing the user plane out closer and closer to the end users. And when I was looking at this architecture, it was occurring to me, how much value is there and how much challenge is there in pushing the user plane out further out. If you have a lot of broadband subscribers and fixed wireless access subscribers all kind of intermixed on one network, your subscriber base might grow substantially out at the leaves of this network. And might there be some value in allowing, not having to backhaul all that traffic, but allowing traffic to U-turn further out towards the subscribers, and also to be able to push edge applications. Of course, that's the hot space right now. So to be able to push edge processing and smart edge apps that want to be low latency, push them out close to users. Wonder where that fits into your thinking in this.
I think that's great. And to be honest, I prefer not to highlight that as such, just because I don't want this to become an implementation manifest type of a thing. I prefer it to be more laying down the problem space and let the community tackle it in the most efficient way. But what you just explained, if you allow me, by basically breaking the user plane function from here, which is actually in both of the two options in my proposal, and push it down there, it's actually allowing us to have two SDN-defined user planes, one for the 5G radio, the other one is for the fiber, on top of these hardware components following the SDKs of the chipset provider that we will leverage. And I think Volta is actually having something very similar to that concept. And this will translate the core to become only a northbound handler / policy enforcement point. And that will allow us not only to optimize for the implementation of the fusion, but also will allow us to optimize for the speed, because now we don't need to carry all that backhaul all the way to a singular position where basically we used to deploy core. I mean, it is core for a reason, correct? We usually have much less of these nodes and a lot of these. So distributing the problem will definitely allow us to go after the whole promise of the initiative, which is how can we get more speed to the end users at a better economical point. And of course, the use of P4 or any other easily programmable way to configure the chipsets is definitely the right way to go, because we want to figure out a way to be able to decouple the hardware from the software when it comes to handling the packets, especially if we are distributing it down on the access layer where the barrier on entry is much less, because we are, instead of looking into hundreds of gigs of traffic at the core of the network, we are looking into a per user traffic where basically getting a more optimized user plane can be easily achievable. And then the final point here is the decoupling itself comes really in line with the new advancement of 5G or wireless technologies overall, like the CUPS architecture, where the control plane and user plane are separated from each other. And this will allow us also to leverage some of the work that we did in these two projects together with the Open Core Network. So that also will make it more extensible to other use cases as such, because now we are basically saying that for that specific Fusion use case, the user plane is the custom built, but the core is the same. So now we can actually add more use cases to keeping the core as a unified component and just customizing the user plane, which I think the right approach. Again, that's an implementation manifestation of one approach. Maybe the people will figure out a better way to get it done as well. So I will leave it to the community to decide on this.
Yeah, Hani, thanks so much. That was really terrific and a good overview. And I would share with viewers out there that ONF also has a spotlight on 5G and mobile and the open source in that space that's coming up in the beginning of September. And a number of these projects here, if they're not familiar to you, and if you're learning about SIBA and Volta in this particular spotlight series, there'll be an opportunity to learn more about certainly SD-RAN and the distributed disaggregated RAN, and then OMAC and COMAC, which is actually merging together both the access networks and the core networks and the user management, all these different aspects that, Hani, you've been touching on it in various ways. So COMAC has had this vision of starting to bring all that together in a unified way. That's still a bit of a vision. We're kind of executing, and the community's coming together on the different pieces of that puzzle. But I think that you've articulated in a really nice way what a possible end state is for all of this, and it makes a lot of sense to me. And I really, really appreciate your time today. Thanks, Hani.
Thank you. Thanks for having me today. Thank you very much.